The Unitree G1 humanoid robot has received a significant agile upgrade, and its performance in recent footage is nothing short of astonishing. The robot demonstrates the ability to walk and jog on uneven terrain with remarkable ease, almost as if it were second nature. Some observers have noted a moment where it nearly trips while descending a step, but recovers so quickly that it's hard to believe such subtle movements are being executed by a machine. The G1's form appears more natural than ever, with many highlighting the smoothness of its gait and the speed of its foot placement. People have also praised Unitree for frequently rolling out updates, with improvements seemingly arriving on a near monthly basis. Comments range from admiration for the engineering team to humorous speculations about how humans might never outrun these robots. The G1, along with other Unitree robots, showcases a surprising range of abilities. They perform tasks such as kung fu moves, navigating challenging environments tirelessly, cooking, cracking nuts, opening soda cans, hammering objects, and even welding in demonstrations. The fluidity of their movements has been particularly striking, with many viewers describing the progress as both slightly intimidating and incredibly exciting. Unitree has also partnered with AI Network to integrate a system called They're Not a collaborative spatial computing protocol. The mesh enables multiple robots to exchange spatial data, allowing them to coordinate movements and operate more efficiently within the same environment. This system reduces redundancy, ensures that all robots share a unified frame of reference, and optimizes resource usage. Robots running POS Mesh can share maps in real time and adapt to changes without relying heavily on local processing power. This coordination capability allows fleets of G1 humanoids or go-to W9 quadrupeds to navigate, distribute workloads, and tackle tasks in parallel. AI Network claims deployment can occur in seconds without the need for complicated manual setups. They believe this innovation paves the way for scalable and efficient autonomous systems, enabling robots to perform complex tasks more intelligently. Beyond this, there's also an intriguing project called Eliza. Wakes Up is working on developing one of the most advanced humanoid robots ever released outside a research lab. The starting point is the Unitree H1, a sophisticated bipedal platform, but the development takes it much further. By partnering with Old World Labs, the aim is to upgrade everything, from the robot's face and hands to its overall realism. The team has added an animatronic silicone face capable of a broad range of expressions, aiming to achieve a high level of emotional connection. Advanced, dexterous hands are being integrated, enabling the robot to handle everyday objects with near-human precision. The skin is designed to be hyper-realistic, and the combination of an expressive face and fluid movements helps bridge the uncanny valley in ways rarely seen before. One of the most significant breakthroughs lies in the robot's brain. Developers have integrated a large language model and Eliza OS v2 by AI60A to create what they call an AI agent. This AI can think, reason, interact naturally, run sophisticated processes, and even interface with blockchain technology. The team envisions it as a physical embodiment of AI, seamlessly moving between digital and tangible worlds. They compare it to Sophia the robot from 2016, but emphasize that today's hardware and software advancements make this project far more powerful, promising unprecedented results. Specifications for the Unitree H1 include height, approximately 180 centimeters, weight about 47 kilograms, walking speed, greater than 1.2 meters per second, athletic performance, potentially up to 5 meters per hour, peak torque density, 189 millimeters per kilogram, battery capacity, 864 watts, enabling operation beyond 8 hours, response time, under 50 milliseconds, 3D perception, LiDAR and depth cameras providing 360-degree depth perception up to 100 meters. As you know, over time, these models will continue to get cheaper and cheaper. But let's take a look at what they've said about the O3 model in terms of its coding performance. We can see that, in comparison to O2, well, it's actually O3, but this is the second iteration of their model. On competitive platforms like Codeforces, this model's consistent personalities emphasize advanced conversational AI and emotional intelligence, supported by a silicone animatronic face that mirrors human emotions and expressions. Physical capabilities include force-controlled manipulators for dexterous tasks like cutting cigars, serving drinks, and even running an 8-minute mile. On the software side, real-time LLM-driven conversation powers interactions, while the hardware enables stable gait and flexible navigation over complex terrain. Observers note that this kind of human-like companion could redefine the future of work, physical AI embodiment, and the connection between blockchain technology and real-world robotics. Other Unitree news highlights the G1 bionic upgrades, showcasing walking and running abilities that observers praise as some of the smoothest in the world. People watching the new video have commented on the G1's ability to recover almost instantly from a stumble during a step down, demonstrating an advanced balance mechanism. Some marvel at how it avoids the typical stiff appearance of machines, envisioning a future where the G1 could be mass-produced. Many remark on how quickly Unitree is advancing, with some viewers joking about playing Terminator music in the background, given the robot's fluid motion and sci-fi-like potential. Meanwhile, robotics research is expanding at the University of California, San Diego. Researchers are using the G1 in a project to teach it to waltz by mirroring human moves in real time. Rather than relying on pre-programmed dance scripts, they leverage AI models trained on human motion capture data. They integrate a system called X-Body 2, which learns to articulate a robotic body through reinforcement learning in a simulated environment. Then, they equip the G1 with another model, enabling it to analyze human motions and imitate them. This allows it to copy walking, dodging, squatting, dancing, or even throwing a punch by referencing its baseline knowledge and applying new movements. Researchers say this approach lets the robot quickly learn new tasks without returning to the lab for every new action. Instead, it can pick up skills through demonstration. This rapid adaptability could cut costs and speed up development, as mirroring or shadowing eliminates the need to build specific datasets for every movement. This might accelerate progress toward robust humanoids capable of handling dozens of tasks. Similar shadowing-based methods have been explored by teams like one at Stanford, teaching humanoids to box or play rudimentary tennis by drawing on motion capture data. Such advancements suggest robots might take on diverse roles, from deliveries and caregiving to serving as tireless personal trainers. They could also handle dangerous or repetitive jobs, improving workplace safety. The G1's ability to weld and hammer suggests a growing industrial role, and as hand dexterity and vision improve, it might even become a feature of everyday life. Watching the G1 run on rough terrain or balance on tracks sparks a mix of excitement and concern. Misuse of a powerful machine outfitted with harmful attachments is a potential risk, yet its agility and intelligence remain captivating. It's crucial that researchers and regulators guide its development responsibly. Eliza wakes up, supported by Rise Labs and AI Combinator, which blend AI, crypto, and advanced robotics to create a new kind of humanoid. Rise Labs finances emerging tech worldwide. Eliza Labs provides the Eliza OS for real-time decision-making and on-chain functions, and Old World Labs specializes in precise 3D printing. This seems like a watershed moment, with actuator and sensor advancements finally enabling tasks once considered out of reach. Truly dexterous hands remain a challenge, but in 2025, regular videos showcase rapid gains in walking, cooking, dancing, and more. I can imagine them sprinting or even mastering parkour soon. It feels like a revolutionary shift, merging digital intelligence with physical machines. Next year, we're likely to see even more advanced systems, redefining what we think of as robots. Are we prepared for this transformation, or is it progressing faster than we can adapt? Thanks for watching, and I'll see you in the next one.